Hey, welcome everyone. At the beginning of every section, I'll have a video similar to this one where I talk about what actually matters in the section. So I try to keep them brief. I just want to highlight of all the topics we cover, what really is worth your time and stress to try and get right versus what could you circle back to later. So I'll use this Trello board I've made for all the topics in this course, and I'll go through the main topics in this section, which is just an introduction to Git, nothing technical really at all. We're just going to cover some important conceptual topics. So all these topics are labeled as green, meaning that they're pretty easy to pick up. Some of the other topics later on are a bit more challenging. But we're going to talk about what is Git. I would say that is probably critical. Understanding the difference between Git and GitHub, critical. Understanding the history of Git, not critical to using and working with Git. There's a video about who uses Git, different use cases. It's not just engineers these days, governments, scientists, writers. I'll say important, on the verge with nice to have. I wouldn't really spend a lot of time on it. What does Git do for us? That is also going to be critical. We need to understand the purpose of Git before we actually learn the commands. So that's pretty much it for this section and what matters. The main takeaways: focus on what is Git compared to GitHub, and what exactly does Git do for us. Okay, let's go. Okay, so let's begin with a very important question. What exactly is Git? So Git is what's known as a version control system, sometimes abbreviated as VCS. Not only is it a VCS, it's actually the world's most popular version control system. So what exactly is a version control system? It doesn't sound all that glamorous. Essentially, version control is software that helps track and manage changes to a set of files over time. Also, doesn't sound all that glamorous or exciting, but hugely important. Think of companies like Facebook or Google with huge code bases, thousands of files, and thousands of developers. They're all working in parallel and making changes day to day. How do you manage those and track those changes and combine them and undo changes? That is the role of a version control system like Git. In general, most version control systems allow things like revisiting earlier versions of files, comparing changes made between different versions and different files, undoing changes, sharing changes with other people. Git does this and more. We're going to go into this in just a little bit, but that's a general intro to this concept of version control. And to be clear, Git is just one of many version control options out there. Over the years, they've kind of come and gone, but some of the more well-known ones include Subversion, CVS, and Mercurial. And they all have similar goals of helping developers or helping users track changes to projects over time, but they do have significant differences in how they operate, the syntax, and how they achieve those goals. But the good news for us, obviously this is a Git course, so we're going to learn Git, but there's a good reason to learn Git. It is the clear winner. If there ever was a version control system war, Git is clearly the most popular these days. This is the most recent data I could find from 3 years ago. 2018 Stack Overflow Developer Survey. Nearly 90% of respondents reported that Git was their version control system of choice. And the thing is, in the last few years, this survey has just stopped asking this question. It's abandoned it because it's just so clear. The number is probably more like 95% these days of developers that use Git. So we're here to learn Git. That's good news for us. I'll end by just showing you what Git calls itself on the Git homepage. It's a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It's easy to learn. We'll see about that. It's not bad to learn, but I wouldn't say it's painless, and it has a tiny footprint with lightning fast performance. It outclasses other tools like Subversion, CVS. Oh boy, look at that, trash talking the competition. Anyway, the stuff we care about is up here. It is a version control system. That is Git at its core. It helps users manage changes to projects over time. In the next video, we'll talk in more concrete terms about what Git actually does. So now that we know that Git is a version control system, a popular one at that, let's talk more about the specific features. What does it do for us? So in this slide, we can see some of the main things Git helps us with. It helps track changes across files, compare versions of a project, time travel back to old versions, take a peek at what something looks like a year ago, take a look at Facebook's code base today compared to 2 days ago, go back to a previous version if we mess something up, combine different changes between versions, between different files, between different collaborators, and that's probably the most important part, collaborate and share changes. Git facilitates collaboration between a team of users, of developers, of writers, whatever people are doing with Git. Git facilitates collaboration and sharing those changes between individual people. So here's a very, very simple explanation. If you've ever played video games, like I have, there are some games that allow you to make save points, little checkpoints you can come back to. And I guess this is supposed to be me. I was always very, very nervous as a game player. Some of the games I played as a kid, where if you died, you would go all the way back to wherever your last save was. So I would always try and save pretty much before anything. So I would save and then get to some horrible boss battle. I suck at video games, even though I like them. I die, but that's okay. I don't get angry because I saved my game. I can just go back to that save point. That is the simplest explanation of Git and what it allows us to do. Set up these checkpoints. You can screw things up entirely, make a huge mess of a code base or of a project, empty all the files out, delete the files. But if you're using Git and you made these checkpoints, you can just go back. So here's another explanation that I've used. In high school and college, I had to write a lot of essays. I did not know Git really at the time. So I did this. I would start writing an essay, and then I wanted to try something new. So I'd save as, I'd make a new version that was V1 or V2 or even more variations. V2 with a new intro or a new conclusion or reorder, all sorts of different strategies. And I would save all of them because I wanted to be able to compare. I didn't want to just have one essay that I had to work in, right? I want to be able to track versions and compare, and it's just part of the process. And then I would end up with some final, but then inevitably, actually, final for real. This is the one, print this one. This was honestly what I did in high school and college all the time. So Git helps with this sort of issue. Now, this is a very trivial situation, but imagine thousands of developers collaborating on a project where they're working on millions of lines of code all at the same time and having these different versions and sharing and combining them. So here's a somewhat more realistic example. I'm working on some project, a website. This is the progress of the website up top. So right now it's empty. With Git, I create checkpoints. So checkpoints are like save files I can go back to. So I have my first checkpoint, initialize project. There's nothing up there. But then I do some work. I add this navbar up top. So I make a new checkpoint, add top navbar. Now I have 2 checkpoints. And then I do more work, right? Some content. So I add a new checkpoint. We'll say add first row, whatever this is. Maybe I'm making YouTube or something. So I add some content, and then I do more work. I add more content. I add a new checkpoint. This workflow is very, very common. You do something in a project. If you're using Git, you make one of these so-called checkpoints. We'll learn what they are and how you do it, of course. And then you keep working. So here I changed the theme entirely. A dark theme, new fonts, new colors, new everything. I add a checkpoint. So I forgot to mention, I work not alone on this. I'm working at a company. I have a boss. I'm not the one making these decisions, right? What stays, if we want this theme or not, or if we want this earlier theme here. But anyway, I do some more work. I alter the navbar color. I make it yellow. I add a checkpoint, update navbar, and then I show it to my boss. Realistically, you don't just show code to your boss, but there's a process for approving or rejecting changes. But anyway, in this simplistic world, my boss gets angry, or maybe not even angry. She just says, you know what, these colors suck. We can't move forward with that. But that's okay. I use Git. I have this series of checkpoints. I can go back in time to earlier checkpoints. So this is what it looked like at this checkpoint, but I can go backwards too. So from before the time I added the dark theme, now we're back to this light theme. And then I could even branch off. I could start working from this point and create a new sort of fork where I can have an alternate timeline. So this work's not lost. I'm just not doing it right now. I'm working on a new version. So I added more content, if you can see that there. So I had 2 rows of content. I add more content now. I've picked up development at this point in time. So I add a 3rd row. Maybe I add a new footer down there. So we get a new checkpoint if I want to add a checkpoint then. And then I could switch back to what I had earlier. At this point, I can toggle between them. I can use Git to say, go all the way back to when I first added the navbar, or go all the way up to when I updated the navbar, I made it yellow, or go to add footer. I can hop around and compare, and I can present both to my boss. They both can exist, which is the crazy part. Git helps us manage all of these different versions. So I can switch back to this dark mode checkpoint, but what's even crazier, I can even combine these checkpoints, the work that changes between the two. So this dark mode had, the dark colors, and add footer had all this extra content with a footer and a third row. So I combined them to end up with a footer and a third row of content and the dark mode colors. So I now have a hybrid. And that's exactly the sort of thing that Git helps us with. Now this is a simplified example, but imagine now I'm working on a project. It's not just me. There's 10 people or 100 developers, lots of files, lots of versions. How do we coordinate all those changes between all of us and combine them, right? We don't all just work in silos on our own. We need to combine that work back into some code base at some point, or whatever we're working on, we share those changes. So it's this times hundreds and hundreds often at a large company. Okay, so that's the basic idea of Git and what it can help us with, just trying to visualize it for you. Next up, I guess totally optional, I'm going to talk about the history of Git. This video, like every video in the course, I guess, is completely optional. But this video in particular, I want to focus on the history of Git just for a couple of minutes. It's kind of fascinating in my opinion, but it's not super relevant to learning how to use Git. So no big deal if you skip it, but let's do it. Let's talk about the creation of Git. So there's a very famous developer named Linus Torvalds. It's probably closer to Linus Torvald, but the Americanized version is Linus Torvald. He is truly a legendary engineer. He's the creator, the main developer behind Linux, but also Git. So very prolific, very talented, and he's always been very pro open source projects, meaning if you're not familiar with the term, code bases that are available for others to see and collaborate on and tweak and try their own things with, instead of hiding code behind some sort of paywall, making it all secret. Anyway, at some point he was working on Linux with a team, and they were using a different version control system called BitKeeper. This is the Wikipedia page for Git. So BitKeeper was a tool that did basically what Git helps you do, manage versions. However, at some point, I guess there was a fight, a disagreement, and the owners, the creators of BitKeeper, did not allow the Linux team to use it for free anymore. They wanted to charge money. They, I guess, removed the license. So this was controversial. It spurred the creation of a couple of version control systems, including Mercurial. But for our purposes, what we care about is that Linus was frustrated. He was pissed off about that. He wanted a free version control system that had features that he desired. And at the time, nothing fit that bill. There were paid services that had those features, and there were free ones that just didn't have the features he wanted. So he wanted to make something fast and open source. And that's actually exactly what he did. He just said, screw it, I'm going to do it on my own. And he spent most of April 2005 just writing code to make Git himself. It's a very impressive effort. So he was unhappy with the existing tools. He got to work. He said, I'll do it myself. And that turned into Git. In just a matter of days, he had the basic functionality done. Now, that doesn't mean that it's a one-man show and that he's in charge of Git to this day. There have been many collaborators. In fact, he handed over development of Git after, I think, maybe the first month or two to some other developers anyway. But basically, he saw a need for a product that didn't exist as a free open source tool. He created it himself, and now it's a huge hit. Everyone uses it, right? 15 years later, over 90% of all developers worldwide use Git on a daily basis. Now, one interesting note is about the naming, the name Git. In development, Linus Torvalds referred to Git as the stupid content tracker, just as his own personal name, but eventually he settled on the name Git, and according to the official source code for Git, you can view this online, there are a couple of explanations for the meaning of the name Git, depending on your mood. So it's either a random 3-letter combination that is pronounceable, that's always good, and not actually used by any common Unix command, okay. The second option of the meaning of Git is stupid, contemptible, and despicable. Simple. Then we have Global Information Tracker. That's the more corporate, cleaned up version. Git, G-I-T, Global Information Tracker. That's for when you're in a good mood and it actually works for you. Angels sing and a light suddenly fills the room. And then when things break and it doesn't work, you can see it is gosh darn idiotic truckload of, you know what? Oh, I always feel like such a goody two-shoes in these videos. I don't want to lead to any angry reviews and commenters, but this is in the source code, right? I didn't put this in there myself. That's in the official source for Git. So the last note that I think is kind of funny, in British slang, it means an unpleasant person. And Linus Torvald sarcastically quipped that he actually named it after himself. He said, "I'm an egotistical bastard, and I name all the projects after myself. First, Linux, like Linus, now Git," joking that he's an unpleasant person. Or maybe he's a gosh darn idiotic truckload of you know what. Okay, so just kind of a fun little bit of history. It's always amazing when one person goes about trying to solve a problem and they succeed, right? And then it just becomes incredibly widely used and widespread. That's exactly what happened with Git. It started with one guy hunkered down somewhere. I mean, incredibly talented developer, right? It's not just like me or you, most likely, but a very talented developer just taking on existing tools and trying to improve upon them with a free open source tool that now is everywhere. Okay, next up, I'd like to talk about who uses Git. So this will be pretty quick as well, and optional. You don't have to know about this in order to use it. But the first most obvious group would be engineers, developers, coders, ranging from people who work on their own little tiny side projects or just hobby projects, entrepreneurs, up to massive tech giants like Facebook and Google. Git is the most commonly used version control system, as we talked about. And when you're developing applications, version control is very, very important to use. On Git's official homepage, they list some of the companies that use it: Google, Facebook, Microsoft, Twitter, LinkedIn, Netflix. And then if you go to a website like StackShare, where you can view, I don't know how accurate StackShare is, but you can view different tools and companies that use them. There's other companies like Robinhood, Reddit, Lyft. StackShare itself uses Git. Smaller companies, Patreon, Fiverr, Canva. I use Canva all the time. Massive companies like Walmart. Anyway, the point is it's used by pretty much any engineering team you can think of. Also, another group that uses Git, or at least would benefit from being familiar with Git, are tech-adjacent roles. So people who are not developers, but work with developers or deal with developers. Learning the basics of Git is not all that difficult, and it can help a lot with conversations, with deadlines, with just, setting expectations. And in particular, designers often need the basic understanding to be able to work with Git and communicate with developers. So another completely separate group of people who are using Git these days are governments and large organizations, not technical, right? They're not, tech startups. Governments use Git a lot to manage the drafting of laws, collaboration of drafting laws, sharing data and large data sets. So Washington, D.C. City Council uses Git and GitHub, we'll talk about GitHub in a bit, to publish its laws and have made it a collaborative process. And citizens have actually found and fixed typos collaboratively in those laws. They've fixed them using Git. So I think I have some examples. Here we are. This is the city of Chattanooga. They use GitHub, which, again, we'll talk about what GitHub is and how it compares to Git. But all you need to know is that it's based on Git. So this project is simple. It just shares parking locations in the city of Chattanooga. And then if we go to GitHub's webpage, they have something called government.github.com. They show actually a whole bunch of different governments that use GitHub, which again is built on top of Git. So governments, groups from Argentina, Australia, the US, the UK, pretty much every country is listed here. Now, that doesn't mean that Git plays a central role in all of these governments. For example, let's see, USGS, the US Geological Survey. They have a whole bunch of things on GitHub, pages and pages of these projects that are shared with the public, and they use Git to manage all of them. Anyway, so that's another group that use Git these days. Scientists also, more and more, are using Git to help collaborate on projects, to share findings and data sets, to manage code and work together on code bases. And Git and GitHub together really work well in an open source or a peer-reviewed world like science and research. We'll learn more about GitHub. I keep saying that, but we will. And some other groups, writers, it's not all writers, certainly. It's not that common these days, but some writers really are becoming fans of Git. I listen to some screenwriting podcasts to fall asleep to sometimes. And every so often there's an episode about using Git to write screenplays, manage versions, right? I talked about having different essay versions. Well, with a screenplay, you've got so many revisions, so many drafts, or a novel, so many characters, so many ways of structuring a novel, ordering things, different arcs. So Git is definitely gaining in popularity there. And then specifically, I've seen multiple use cases of Git for collaborative textbook writing, where textbooks usually have multiple authors. So this is a book, a textbook on informal homotopy, I think it's homotopy type theory. I have no clue what it is, what the book, this means nothing to me other than the fact that it's a textbook on something crazy sounding. But a lot of people have used this textbook. It looks like a couple of thousand people have started. So it's like a favorite of their projects on GitHub. And here we'll see there's 85 people who have collaborated to write this textbook. Just one simple example. Now, the last slide. Anyone really can use Git. People find all sorts of creative uses, from keeping a daily diary to writing their PhD thesis with Git, all the way to composers. I saw a Reddit comment from a composer who writes symphonies, and he uses Git to help track the massive changes, all the different files, the parts, as his symphonies evolve over time. It's a multiple month process to write a symphony for a full orchestra with all the different instruments written out. He uses Git to help with that. So I assume a lot of you who are watching this are probably in this group, right there, or maybe this group. But increasingly, I expect in the next few years, there'll be more governments, more scientists, more writers, more symphony composers who use Git, because it really can be, I won't say a life changer, maybe a lifesaver. It can save you a lot of stress and time down the line, assuming you can get past the initial hurdle of learning it. We are on the precipice of learning it, so I'll shut up. So next up, I want to talk about an important distinction, the difference between Git and GitHub. This course does cover both. They are closely related, but they are not the same thing. So Git, as we've been talking about, is this version control software. It runs on somebody's machine. It runs on my laptop. It runs on your desktop or whatever. It runs on people's computers. It doesn't need internet. You don't need to register for an account. It's just something that you download if you don't have it yet, and then you use it on your machine. You could never have internet ever, and you can still use Git. In the same way that you could, if you had like a text editor or Microsoft Word or Excel, you can create those documents. You don't need the internet. You don't need to sign up, although I don't know, maybe these days Microsoft needs an account. I don't know, but whatever, text edit, you can just write text documents whenever. GitHub, on the other hand, is a service. It's a web service. And what it does is it takes Git repositories, that's the fancy way of saying Git projects, and it hosts them, it stores them in the cloud, and makes it easier to collaborate on them with other people. So it's a website you do need an account for. You do need the internet to use it, and it takes the stuff you do locally on your laptop or my laptop or whatever using Git, and then it allows us to put that online and share it with other people, or the other way around. Other people can put their stuff online, and then we can get their code or their Git projects on our machines. So it connects people. It connects Git projects. And in this course, we're going to start with Git first. You kind of have to. We don't have a choice. We have to understand how Git works and the different commands before we can move on to GitHub. So that will come second, although it's not like the course is split exactly in two, because we do cover some Git content after we learn more about GitHub. So just to try and visualize this or help you visualize it, if this is my project I've been working on locally on my machine, no internet, no collaborators involved, and this is my Git history, I have a whole series of these checkpoints. If I wanted to share this with other people and collaborate with them, I could put it up on GitHub. That's what I'm showing here. There's a cloud. That's the GitHub logo. I'm taking this work and all this history and putting it online on GitHub for some collaborators or maybe for the whole world to see. Then those collaborators, here we've got 2 people, they can take that work and get it on their machine. They can add on, they can modify it, they can do their own work, and then share that back up to GitHub, and then I can go and get it from GitHub, and we can all work together. So all of a sudden, we can have lots and lots of people collaborating on projects thanks to GitHub. That is something we will learn. It's kind of a separate workflow, a set of skills that you need in addition to just understanding the basics of Git. We have multiple sections of GitHub ahead of us, but first, as I've said, we're going to start with Git. So that's all I wanted to say here. I just wanted to make that clear. Git and GitHub are not the same thing. GitHub definitely requires some knowledge of Git. It is a tool that is built for Git and for Git users, but you could live your entire life as a Git developer never touching GitHub. Anyway, we'll talk more about it later on. Let's focus on Git for now.